Hey guys, welcome to the 8.3 Ellipses notes. Make sure you have a copy of this sheet of paper as well as an assignment. And I'll go ahead and get started. Alright, so essentially what we're going over today is how to go backwards and write the equation of an ellipse given either information or the graph. And I have given you a couple of formulas down here. If the ellipse is horizontal, that just means that the bigger number A is underneath X. If it's vertical, it means that the bigger number A is underneath Y. So it doesn't really look different other than the bigger number is underneath a different variable. For the first step, what we have to do is decide what the center is. Now, I am going to go ahead and write something down that you may write in your notes as well. You may want to. Is that this is technically going to be x minus h squared and y minus k squared. I had just kind of left it off for a second to kind of show you the difference between A and B in a horizontal versus a vertical ellipse. But I realized that that is a little confusing, so I wanted to go ahead and also show you that you can add it there too if you want. Okay, so basically you need to find three things. The center is the first one. It is always going to be the midpoint between any of the other 2 points, either the vertices or the co-vertices or the foci. It doesn't matter which ones you use. They're all going to give you the center as the midpoint. So you can use any of them that you want to. The second piece that you need to know is the letter A, or the value for A. This is the distance between the center and the vertices, which is always longer than the distance between the center and the co-vertices, which is B. So essentially we need the center, the vertices, and the co-vertices. We need three things because we need to decide what A and B are. A and B are the only two letters that we really have to figure out for this formula. That and the center. And that's pretty much it. So A, B, H, and K. And then you just plug them all in. Just remember that A is always bigger and goes underneath the variable that is that far away from the center. Here's how this works in an actual example. And then I'll get to step 4 after we do a couple. Okay, so in this first one on the far left, it is pretty obvious that your center is right here at 0, 0. That means that it's just going to be x squared and y squared on their own. And we already should know that the equation to an ellipse always equals 1. Now, for the x part, you just count how far away the x axis is from the ends, which is 1, 2, 3, 4, 5, 6. That's 6. 6 squared is 36. Boom. Done. And for the y part, 1, 2, 3, 4. 4 squared, 16. So it's x squared over 36 plus y squared over 16 equals 1. Now, on this particular one, it didn't really matter which one was shorter or longer. It does matter with some of the equations down below that give you the information instead. So that's kind of why I brought that up earlier. Okay, let's try another one. If you're given the graph, you look for the center first. This one is also 0, 0. So it will also start as x squared over and y squared over equals 1. Then you just count it out. In the x direction, it's going over 1, 2, 3. 3 squared is 9. So it'll be x squared over 9. And in the y direction, it's going up 1, 2, 3, 4, 5, 6, 7. So 7 squared is 49. Now, I am going to pause and say one thing. It does not matter what order x squared and y squared go in, other than why would we change it if we don't have to. Y squared is going to automatically end up with a bigger number underneath if it's a vertical ellipse, and x squared is automatically going to end up with a bigger number underneath if it is a horizontal ellipse. That does change for hyperbolas, though. In a hyperbola, it's whichever one goes first, not whichever one's bigger. So this does get a little bit trickier in the next lesson. Okay, we have one graph left. This one is not centered at 0, 0. In fact, it is centered over here. It is over 3 and down 1, 2, 3, 4, 5, 6. So 3, -6, which means you're going to have x minus 3 squared and y plus 6 squared. Equals 1. That's really the only difference, is we had to actually count it out. Then the x direction is 1, 2, 3, 4, 5 away. 5 squared is 25. And the y part is 1 away. 1 squared is, be careful, 1. Some people think that 1 squared actually equals 2. It does not. And that is how you write it from a graph. Now let's talk about how to do it without a graph, which is always going to be a little trickier. So with the first two on the top, you'll see that you're given the vertices and the co-vertices. The first thing you should always do, no matter what type of conic section it is, circle, ellipse, or eventually we'll learn about hyperbola and parabola, is find the midpoint. So for the center, we need to find the middle point between -5 and 5. So we would add them together and divide by 2. Or I'm kind of hoping that some of us know that exactly halfway between -5 and 5 is 0. Because -5 plus 5 is 0, and 0 divided by 2 is 0. And then you would add your y values and divide by 2. Well, halfway between 0 and 0 is still 0. So that's my center. I'm just using these two vertices right here to do my midpoint formula. And it's actually going to be the exact same thing if you use your co-vertices, because halfway between 0 and 0 is 0, and halfway between -2 and 2 is also 0. So it does not matter which one you use. Now that I know that piece, I can go ahead and start my equation, x squared over plus y squared over equals 1. Now, your vertices are always going to be the bigger number. The part you have to pay attention to is between here, between my center and either one of my vertices, doesn't matter which one, which variable is changing. Hopefully you notice that x is changing by 5. You subtract 5 to get the -5. You add 5 to get +5. So 5 squared is going to go underneath the x part of the fraction. And over here for the co-vertices, the distance between the two y values is 2. And again, it's the y by 2. So 2 squared, or 4, goes underneath the y part. And that's pretty much it. There is a lot of counting in your head that makes this a lot easier. Okay, let's keep going and keep trying some more. If you get stuck or need to pause, feel free to rewatch. For the vertices, I have 5, 8 and 5, -6. You'll notice that 5 is the same on both of the vertices. So guess what? That's going to be the first part of the center also. Because halfway between 5 and 5 is 5. But I don't know what the y value is because it's 8 and -6. So I can just add them together and divide by 2. 8 plus -6 is 2. And 2 divided by 2 is 1. So my equation is going to be x minus 5 squared and y minus 1 squared equals 1. Then for the numbers on the bottom, you just have to pay attention to which variable is changing. For example, on the vertices, the 5 is the same, but you go from 1 to -6. That's a difference of 7 in the y direction. So 7 squared goes underneath y. Pay attention to which number is changing. It doesn't help you to go, oh hey, 5 to 5 is 0, because you can't use 0. Then for the co-vertices, it is the x value that changes from 5 to 11. The x's are changing by 6, because 5 plus 6 is 11. So 6 squared, or 36, goes underneath. One more time, pay attention to which variable is changing, not which one stays the same. Okay? These last two get a little bit tricky because they give you the co-vertices and the foci, or the vertices and the foci. However, it still starts the same way. You can't do anything until you find the center. So halfway between 2 and 2 is 2. Halfway between 7 and -9, I'm not sure, so I'm going to add them together and divide by 2. 7 plus -9 is -2, and -2 divided by 2 is -1. So I've got my center, which means I can set up the first part of my equation. And I just need to find the distances that go on the bottom. Now, as I go to find from my co-vertices to my center, my y value is changing by 8. Except for what we need to know is that that is the value for b. Because co-vertices are always b units away from the center. So, I have b. Foci are always c units away from the center. So from 2 to 8, I'm going up by 6. So that's the x's by 6. But that is C, not A or B, because technically up here, A is the vertices, B is the co-vertices. A is the vertices, B is the co-vertices. But since I only needed A and B, I could just solve it. The issue here is I don't have any clue what A is because it doesn't give me the vertices. So what you have to do, and it says it up here at the top, because this is the one that gets tricky. If you are given the foci, the second you see foci on the problem, you need to know that you are going to use this to find whichever one is missing. So since I'm missing the vertices right now, that's the one I'm looking for. I'm going to go ahead and write A above vertices and B above co-vertices so that you always know A gives you A comes from the vertices, B comes from the co-vertices. So I'm going to use C squared equals A squared minus B squared. C is 6. So 6 squared equals A squared, which I don't know, minus B squared, which is 8 squared. Going to go ahead and actually solve. 6 squared is 36. 8 squared is 64. And then I add that 64 to the other side. Well, it turns out that 36 plus 64 is 100. So 100 equals A squared. That was what goes underneath the x part. because b is already 8, but we said that that was y. So that 64, or 8 squared, has to go underneath y. So the only way I was able to tell which one the a went underneath is by knowing which one the b went underneath, because it's whatever is left. It gets a little tricky, but you have to use c squared equals a squared minus b squared. And I know it's kind of annoying because you have to do all this extra side work. Let's try it one more time though. This time I get the vertices and the foci. So if you want to automatically put A and C, like I could have put B and C here. That might help. I just needed to show you why that might help before we actually do it. So first things first, you have to find your center. Halfway between 0 and 0, or 0 and negative 10. So I misread that one. 0 plus negative 10 over 2. And I should write that as 0 plus negative 10, because you're adding them together and dividing by 2. And then I know that halfway between 6 and 6 is 6. Negative 10 divided by 2 is negative 5. And there we have our center. So I can go ahead and set up this part of my equation. Then I look between my center and either of my vertices, doesn't really matter. I notice that 6 is already the same, so that's not what's changing. But now the x value is going from 0 to negative 5. So the x is changing by 5, and that is going to be my a value, because it's, again, the vertices, which always gives you a. So I can go ahead and put 5 squared, or 25, underneath the x part. Then I look at my foci, and I see that from my center to my foci, the 6 is already the same. But negative 5 to negative 2 means that the x's, are going up by 3. But that is C this time. Which also tells me that I don't know what goes underneath Y, because the Y's haven't changed. They were 6 on everything. So then I have to go straight into C squared equals A squared minus B squared. So 3 squared equals 5 squared minus B squared. Or 9 equals 25 minus b squared. I'm going to subtract that 25 to the other side. Negative 16 equals negative b squared. The only really important thing here is that you divide by negative 1, so it makes both of them turn into positives. So b squared is 16, and that's what goes underneath. That does technically mean, FYI, that the y parts would be 4 away, because it would be the square root. But we don't actually need to find that. And there you have it.